students, in this video we are going to see a problem based on discrete time convolution. So here they have given impulse response of LTI system as h of n equal 1, 2, 1, minus 1, but they have mentioned the origin over here, and origin is this point. That means this is n equal to 0 instant. An input signal to the system is given as x of n. Which is 1, 2, 3 and 1, and they mention the origin is over here. And now what we need to do, we need to obtain the output y of n using convolution sum formula. So what we will do, we will find out y of n, and by tabular method we will verify as well. So over here, first step is that we need to see how the signal will look like by plotting it. So the plot of signal will be like this. N equal to 0 is mentioned over here, so it has to be n equal to minus 1. So this is n equal to minus 1, then we have 0, 1 and 2, and signals will be like this. Here it is 1, n equal to 0, we have value 2, then once again it is 1, and in the end it is minus 1. So this is h of n, and x of n will have the span from 0 to 3. With the values 1, 2, 3 and 1 for n equal to 3. These are the two signals that we have. Now with the help of these two signals, we will see how the convolution will look like. Step number 1 is to replace this n by k to obtain h of k and x of k. So first, x of k we will get like this. And h of k is like this. What we have to do? We have to do a time reversal of h of k to obtain h of minus k. So h of k is like this. We will get h of minus k will have the span from minus 2. Then we will be having an instant at minus 1, then 0, and in the end 1 with the signals -1, 1, 2 and 1. So this is h of minus k. Now we have to consider this h of minus k as a time shifted version of h of minus k by the amount 0. That means if I use this as a shift n equal to 0 in the formula of convolution sum, which says y of n as summation k from minus infinity to infinity x of k into h of n minus k. Meaning in the convolution sum formula, if I put n equal to 0, in the end I will get this as h of minus k, which is nothing but this signal. So what we will consider, our convolution has started with this instant where shift is n equal to 0. So we need to check in this too how many sample points are common. So here n equal to 0, this is also n equal to 0, 1 point I am getting, plus one more point I am getting like this. So in all I will get 2 sample points common between them, so that y of 0 I can say 1 multiplied with 2 plus 2 multiplied with 1, which is nothing but 2 plus 2, and I say y of 0 is 4 for n equal to 0. So first output sample I am getting like this. Now let's go ahead for the shifting, which we will do in the left hand side, delay of h of minus k 1 by 1. So let's delay it by 1 unit, which is nothing but n equal to minus 1. So if I delay it by 1 unit, this particular signal will have the span from -3 to 0. With the values -1, 1, 2 and 1. This is h of -1 minus k. This we need to multiply with x of k having the span from 0 to 3. With the values 1, 2, 3 and once again 1. So this is x of k. We need to check common sample points. Only one sample point common between them. So I can say y of -1 is 1 multiplied by 1. So y of -1 is equal to 1 for n equal to -1. Now if you see properly and if we shift for one more unit, I will not get any sample points common, because if I shift it by 1 unit or delay it by 1 unit, it will start from -4 and end at -1, where no signal exists for x of k. So what I can say now, For the shift which is less than -1, meaning -2, -3 and so on. So for this shift, I can say there are no sample points common between h of n minus k and x of k. Hence, it is quite obvious that y of n will be equal to 0 for n less than -1. That means now we can stop our sequence delaying further. Now let's go to the advancement of the signal, and which will start from n equal to 1. Now h of minus k, I'm going to advance by 1 unit. So it will have the span from -1 to 2. Now the values are -1, here is 1, 2 and 1, h of 1 minus k. This we need to multiply with x of k, which will have a span from 0 to 3 only, with the values 1, 2, 3 and 1. So we need to check how many sample points are common. Why we are doing this? Because we need to do the multiplication, and multiplication exists only if there are the sample points exist between the two signals. So here one signal, another sample point, and we have one more sample point like this. So I can say over here now y of 1 is 1 multiplied with 1 plus 2 multiplied with 2 and finally 1 multiplied with 3, which will give you 1 plus 4 plus 3. If you solve, you will get the answer as 8 only. So 8 is the answer for n equal to 1. Let's go ahead for n equal to 2. That means we have to delay this, repeat. We have to advance this by 1 unit. So it will have the span from 0 to 3. With the values -1, 1, 2 and 1 for n equal to 3, h of 2 minus k need to be multiplied with x of k, which is having the span from 0 to 3, and the values are 1, 2, 3 and 1. Now over here all the 4 sample points are common. So y of 2 will get minus 1 getting multiplied with 1 plus 1 multiplied with 2 plus 2 multiplied with 3, and finally this sample point will have the value as 1 multiplied with 1. So we'll get minus 1 plus 2 plus 6 plus 1. The answer we'll get is 8. Let's go ahead for the further overlapping. So for that I need to shift this by 1. So we will have n equal to 3, where this will have the span from 1 to 4. With the values minus 1, 1, 2, and this is 1. H of 3 minus k. And then we have over here x of k, which will have the value 0, 1, 2 and 3, and the values are 1, 2, 3 and 1. This is x of k. We need to multiply this, and for that we need to check how many sample points are common. So over here 3 sample points are common. And if you solve, we'll get y of 3 as minus 1 multiplied with 2 plus 1 multiplied with 3 and 2 multiplied with 1, and we'll get y of 3 as minus 2 plus 3 plus 2. The answer is 3. This is for n equal to 3. Now we'll further advance it by 1 unit, because we need to check the instant where the sample points are common. If you are not getting any sample points common, then we will have to stop. Right now I can get a sample points common, hence I will shift it by 1 more unit, that is n equal to 4. So we'll get a signal like this, which will have the span from 2 to 5. With the values minus 1, 1, 2 and 1. This is h of 4 minus k. We need to multiply with x of k having the span from 0 to 3, values 1, 2, 3 and once again 1. So this is x of k. We need to check how many sample points are common. So over here we have 2 sample points common. Which will give y of 4 as minus 1 multiplied by 3 plus 1 multiplied by 1. So it is minus 3 plus 1. So y of 4 we will get as minus 2 for n equal to 4. if you see properly, for one more shift I will get a sample point common. So we need to do it for n equal to 5. This will be advanced by one more unit so that have the span from 3 to 6. With the values -1, 1, 2 and 1. So this is h of phi minus k, which we need to multiply with x of k having the span from 0 to 3 with the values 1, 2, 3 and 1. Sample points which are common over here is only 1, that is n equal to 3. So I can say y of phi as -1 multiplied by 1, which is -1. So in the end I say y of phi is -1 for n equal to 5. Now what will happen beyond 5? Beyond 5, this will have the span from 4 to 7 where x of k does not exist. So now I can say for the range n greater than 5, that means 6, 7, 8 likewise. So for this range I can say there are no sample points common, or you can say overlapping, between x of k and h of n minus k. Hence I can say y of n will be equal to 0 for n greater than 5. So now what we have done, all the values for all the shifts we have calculated. Now we can write. So I can say the output y of n will be 1, 4, 8, then 8, 3, -2 and -1. And over here we got a value which is 4 for n equal to 0. Hence our origin will be over here. So this is the instant where I am getting n as 0. Now let's verify with the tabular method. So quickly we'll write x of n column wise and h of n in this row. So x of n is 1, 2, 3 and 1, and h of n is 1, 2, 1 and -1. So we can form this table. So in this table, if we solve this, I will get 1, 2, 1 minus 1, 2, 4, 2 minus 2, 3, 6, 3 minus 3, and finally 1, 2, 1 minus 1. And if we form a diagonal like structure, we can divide this table in this form, and all these things we need to add. And from this we will get y of n as first element is 1, then 4, then 8, 8, 3, minus 2 and minus 1. Now how to decide a 0? It's quite easy. They mention x of n origin is over here and h of n origin is over here. So we need to find out where these two are intersecting. So these two are intersecting in this structure where I got y of n as 4. So I can easily say this is an instant where n is 0, or it's the origin of y of n. Moreover, we can check here number of elements in x of n are 4, number of elements in h of n are also 4. So y of n should have the number of elements m plus n minus 1, which is 4 plus 4 minus 1, which is nothing but 7. 1, 2, 3, 4, 5, 6, 7. So in all the dimensions, these answers are matching, hence we can say convolution is correct. So the thing is that over here origin is shifted now. So even if the origin is shifted, still we can solve the convolution problem. Thank you.